Welcome back, students. Hope you have understood the concept of chi-square test and how it is hypothesized, how we can select or accept the null hypothesis or reject the null hypothesis. What is the critical value? What is the cal value of this? Now, here in this case, we'll be trying to take a problem, okay, and we'll try to solve this problem so that we can understand clearly how we can apply this chi-square test knowledge into our practical life. Herein, it is said that Infosys has changed their old HR policy. HR Director Mr. Arvind wants to understand their old versus new HR policy effect. That means how much it has the acceptance among the employees. Data is given as below, which is the observed data it is given. Calculate goodness of fit in 95% confidence level. Now, what is the data is given? Let me explain. It is given that old policy versus the new policy acceptance. This is old policy versus the new policy acceptance against north, west, east, south of the country. Now that means, let's say they have the four different offices in north, west, east and south, and from each and every offices old policy was accepted by 45 people, from west 40 people, 45 and 70, and the new policies are observed value the is 55, 70, 45 and 50. Now is that the required one? Okay, whether actually it is accepted or rejected by the employees, that Arvind as an HR director wants to know. Now what we need to do, these are the observed value, very simple: 45, 40, 45, 70, 55, 70, 45 and 50. We are having this total 8 observed values, and against that we need to calculate 8 different in each and every cell expected value. Now we know the expected formula value to calculate the expected value formula is nothing but E equals to column total multiplied by row total divided by gross total. Clear? So that means I need to know which one is column total, which one is gross total, and what is that, right? So herein I'm adding these things. Okay, so this is the column total. Column total is 45 plus 55, which is 100. This is 110, this is 90, this is 120. Clear? Now similarly I will have the row total. So what is the row total value? 45 plus 40 plus 45 plus 70, which is 200. 55 plus 70 plus 45 plus 50, which is 220. And this is the gross total. That means either you make it this or this addition, both will be same. So 200 plus 220 will be 420. This is nothing but gross total. Now you have all the value: CT, RT, GT. Clear? Now each and every cell we need to find out the expected value. Now let's say north and old, this is the expected value of against this observed value I need to calculate. So I'm naming it as expected value north old, okay, is equal to 100 column total multiplied by row total, which is 200, divided by gross total, which is 420. So I am getting it 48. So in short, 48 is the expected value against 45 observed value, and we represent by circle. So that means in short the expected value is represented by circle. Similarly, expected value of north new is 100 multiplied by 220 multiplied by 220, this is 220, okay, divided by 420. So that means I am getting the value of 52. So this is the value of 52, this cycle. Similarly, expected value of, let's say, west old. So west old means this one. I want to calculate this observed value. 110 is the column total multiplied by 200 is the row total divided by 420 is the gross total. So it is coming 53. That means the expected value is 53. Similarly, expected value of west new, that means this one, will be 110 column total Row total is 220 divided by 420 is nothing but 57. So this is the value is 57. Similarly, if we calculate, we'll be getting the values, expected values like this: 43, 47, 58, 62, and all these values are represented or denoted by the circle within the circle. Clear? So this we have understood what is the value of this, value of the expected value, what is the gross total, and so on, so on and so forth. Now let's make it in a table. Let's put all these 8 observed values and 8 expected values in a table so that we can calculate that O minus E square, summation, divide, and so on and so forth. We can apply the chi-square formula. So these are the observed values which is already given: 45, 55, 40, 70, 45, 70, 50, 8 observed values, and we have calculated these expected values: 48, 52, 53, 57, and so on and so forth. So 43, 48, 52, 53, 57, 40, 43, 47, 58, and 62. This we are having with us. Now what we need to do, we need to calculate the using the chi-square test formula. We need to find out the chi-square cal, that formula, and then post to that we will try to find out the critical value, and then we will try to compare, okay, whether critical value is lesser than calculated value or calculated value is lesser than critical value, and accordingly we will try to understand the hypothesis. But before that, we need to understand few things. In this case, row equals to 2, column equals to 4, right? See, row equals to 2 rows, correct? And column is 1, 2, 3, 4, 4 columns. C equals to 4. Clear? So in this case, row equals to 2 and column equals to 4. So degree of freedom will be R minus 1 multiplied by C minus 1, which is 2 into 4 equals to, 2 minus 1 multiplied by 4 minus 1. That means 1 into 3, which is equal to 3. Okay, so degree of freedom is 3. That we need to understand, because this is required to see the chi-square table and find out the critical value. Clear? Now before we move ahead, we need to make the hypothesis. Now what will be the hypothesis? So I am making this hypothesis that null hypothesis is old policy effect, old policy effect. That means in short, I'm trying to understand the dependency, correct? Dependency. So old policy effect has no difference with the new policy effect. Clear? And that is the null hypothesis we have understood before, how to create the null hypothesis when it is there is no difference. Clear? So there is no difference in between the old policy effect and the new policy effect. Is it clear? Now what will be the alternate hypothesis? It will be not equal to, right? So old policy effect, this is independent, correct? This is independency. Now old policy effect, that means I am trying to find out the dependency now. Dependency, clear, has effect of the new policy. It means what? In short, null hypothesis is saying old policy and new policy is same. There is no effect, no difference. So it is indifference or independent. Alternate hypothesis, no, there has a difference. So old policy effect has different effect of the new policies. Clear? Or the new policy has a different effect of old policy. It's not same. So now we are trying to find out through this the dependency of that. Is it clear? So null hypothesis and alternate hypothesis we have performed. Now we need to calculate the chi-square cal value and the chi-square critical value. For that, what we need to do, we need to find out this one, this formula, right? Because chi-square value of cal is nothing but summation of observed value minus expected value whole square divided by E, whole summation. Clear? So if we do that, what we are getting. So we are getting here summation of O minus E square is O minus E square divided by E total. So O minus E square divided by E, if I take a summation, I am getting 11.85, 0.919, 0.17, 3.20, 2.96 plus 0.09 plus 0.08 plus 2.48 plus 2.68. So in total, I am getting the summation of O minus E square divided by E, this value. Clear? So this is nothing but 11.85 together I am getting, which is the cal value. Now I need to find out the critical value. So critical value, chi-square critical, chi-square critical, if I need to calculate, we need to take a help of this chi-square distribution table. Now this you can get from internet. Even I have attached the chi-square table also after this lecture as a resource, downloadable resource. But also you can go to Google, you can search the chi-square distribution table, you will get the similar table. There is no difference in that. Okay, only thing you need to remember that how to read the table is this side is the degree of freedom and this side is the confidence level. So herein, as per this, the degree of freedom is 3. So I am considering this one, this row. Clear? And the alpha value is I have considered 0.05 or 0.05. It is said 95% confidence level. It is nothing but 0.05. So in this case, this one. So what is the intersect point? This is the intersect point. The value of this is I am getting 7.81. Clear? 7.81. This is the critical value. Now let me write this in this way. Chi-square cal. Okay, now we need to compare whether chi-square critical value and what is the relation in between chi-square cal value and chi-square critical value. So chi-square critical value. So this is given, chi-square cal is 11.85. This is we have got from chi-square table is 7.81. So obvious this is greater than critical value. Clear? So if this is the greater than critical value, we know what is the assumptions we made, that we reject null hypothesis. Clear? Clear na? So what we considered, if chi-square cal value is less than chi-square critical value, we fail to reject null hypothesis. That means we are supposed to accept. But in this case, we have got the second option, which is chi-square cal value is more than chi-square critical value. So in that case, we reject null hypothesis. The moment I reject null hypothesis, that means I am accepting by default the alternate hypothesis. That means there is a significant effect of the new policy, okay, against the old policy, HR policy, what was there in Infosys. Clear? Again I am repeating, it means there is no or not same effect of new policy versus the old policies. Clear? Now here in this case we can say hence that new policy is useful for Infosys across north, south, east and west. But if it was different, we failed to reject the null hypothesis, then we could say HR policy is useless. There is no difference between the old one and the new one, so why you should implement the new one? Done? So this is the example of that. But this critical value and the before I wind up, let me draw it graphically. So let's say this is the data and we are getting chi-square critical value is 7.81 and chi-square cal, which is more than 7.1, right? So chi-square cal is 11.85. Clear? So this is lying in under this region, and that is the reason we reject null hypothesis, because this is called the rejection region. If chi-square cal value would supposed to be here, then we never could have reject the null hypothesis. But in this case, it is lying here in this rejection region, and that is the reason we reject the null hypothesis. And we can say that new policy is useful for Infosys across north, south, east, and west. Clear? Hope you have understood this.